All right, so let's do some examples of areas of triangles, trapezoids, and rhombi. Get a nice shot of these two triangles and hit the pause button. See if you can figure out the answers, the areas, before I show you. Make sure you see on that second one, the answer is not 50. If you think it's 50, you got to figure out what you're doing wrong. It's not 50. All right, so I'm going to assume you gave it a shot. So this one is a triangle, so the area is 1/2 base height. So I need to figure out the base, figure out the height. Well, I got the base, don't have the height. That's the number I need, perpendicular to the base. Well, right triangle, one missing side, Pythagoras to the rescue. X squared plus 8 squared is 10 squared. And if you do that out, you're going to get 6 meters. It is, of course, a Pythagorean triple, just a multiple of the 3, 4, 5. So it's going to be 1/2 of base 8 times height 6. 1/2 times 8 is 4. 4 times 6 is 24. 24 meters squared. There it is. Second one. It's a triangle, so it's going to be area is 1/2 base height. 1/2. So I got to figure out, well, I know the base is 10. I got to figure out the height here. The height would be this, perpendicular to the base. Well, I know that whole thing is 10. And we got to be careful about saying, can we just split this into 5 and 5? Do we know that this is bisecting the bottom side? Maybe it's 6 and 4. We got to be careful here. What we do know is, either because of hypotenuse leg, matching the hypotenuse leg, we have congruent triangles. So we do know, in fact, that these are congruent pieces, 5 each. But also think about the angles in that original equilateral triangle. Equilateral triangles, the angles are 60, 60, 60. If that's 60 and that's 90, this must be 30. Same thing on this side. And on a 30, 60, 90, most important thing of the year. Special right triangles and Pythagorean theorem. Hypotenuse 10, short leg 5. If the short leg is 5, the long leg is 5√3. So there's the height, 5√3. So the answer is going to be 1/2 times 10 is 5, 5 times 5 is 25, 25√3 centimeters squared. All right, you can rewind that if you need to. Get a shot of this one. Hit the pause button and try. The question is, what's the area of this quadrilateral if AB is 20? So that's a little bit of a weird one. This isn't a trapezoid or a rhombus, just some quadrilateral, which we don't have a formula for, but we do have a formula for triangles. And we can look at this figure as this triangle plus this triangle. So what's the area of this triangle? Well, base 20, height 12. 1/2 base height. So that takes care of this triangle. Then I need to add this triangle. So that's going to be 1/2 of that base times its height, and its height perpendicular to that base is 10. I'm sorry, where did I get, this should be a 12, not a 10. Hopefully you're all yelling at your monitors. Let's try that again. 1/2 of 20 times 12 is 1/2 base height for that triangle, and 1/2 of 20 times 10 is 1/2 base height for the other triangle. So I guess that comes out to be, this comes out to be 120, and this comes out to be 100, so I guess 220 units squared. If there's no units given, you don't have to give me a unit. 220 is the area. All right, now take a look at these two. Get a good shot of a trapezoid and a rhombus. Can you get the area of each one? So assuming you paused it and tried it, area of a trapezoid is 1/2 height times the sum of the bases. The height is the 5. The bases are 3 plus 9. So half times 5 is 2.5. 3 plus 9 is 12. 2.5 times 12 is 30. There's the answer. Fast way. Check this out. Notice that the formula says to add the bases together and multiply times the height times half. But remember, these can be done in either order. So think about flipping these around. If I add the bases and multiply by half, that's the same as adding them and dividing by 2. And if I have two numbers that I add and divide by 2, that's called taking the average. So this and this combine really just say average the bases, and then it's multiply by that height. So let's try that over here. Average the bases. What's the average of 3 and 9? Add them up, divide by 2, you get 6. That's the average of the bases. And then you multiply that 6 by the height, and certainly we get 30. Very nice. Okay, the rhombus. 4 congruent sides. So the formula has something to do with the diagonals. So can I figure out the diagonals? Well, sure. Pythagorean theorem again. Right triangle. I know this is 5. X squared plus 12 squared is 13 squared. And I know in a rhombus, diagonals bisect each other. 5, 5, 12, 12. So I have my diagonal lengths. Area of a rhombus is 1/2 d1, d2. So this diagonal is 24. The other diagonal is 10. 1/2 d1, d2. Half times 24 is 12. 12 times 10 is 120. That's the area of the rhombus. How about these two? I give you the area of the trapezoid and the triangle. You have to find x on this trapezoid, and you have to find h on that triangle. All right, so let's see. For trapezoids, the area is half height times the sum of the bases. I'm going to fill in everything I know. I know the area is 32. I know the height is 4. I know one of the bases is 6. The other base is the x that I'm looking for. So this is just a little equation I need to solve. 32 equals 2 times 6 plus x. Half times 4 is 2. You could either divide both sides by 2, or you could distribute the 2. So subtract 12 from both sides, and then divide by 2, and I think you're going to get x is 10. There it is. How about over here? This is a triangle, and I know the area. Area of a triangle is half base height. Fill in everything I know, including the area of 14. I fill in the base, which is 7. The height is my x. 14 equals 3.5 times h. I think I said x before, it's h. So divide both sides by 3.5, and the height is 4. So there's that one. Now, here's a bonus for you. This is not in your book, and this is going to save you tons of time in chapters 11 and 13. A formula for equilateral triangles, not in your book. And every year my students tell me at the end of the spring this was their favorite area formula when I ask them. And I know that you can't imagine having a favorite area formula. Trust me, if you're going to have one, this is it, because of the amount of time it's going to save you. This is not in your book. There is a formula we can get for the area of an equilateral triangle. If all the sides are s, just check this out. 60 degrees, because they're equilateral. This would be the height of the triangle. That s, to be clear, is the entire base. And if that's 60 and 90 and that's 30, and 60, 90, 30, then I can work with this special right triangle. If the hypotenuse is s, then the short leg is going to be 1/2 s. And if that's the short leg, then the long leg is 1/2 s root 3. This is our special right triangle work from chapter 8. Short leg times root 3 gets you the long leg. And if we put all this together, the area of this equilateral triangle must be, well, we know for starters from the previous video, any triangle is going to be 1/2 base height. But look what happens if we fill in the base, which was S, and we fill in the height, which is 1/2 of S root 3. So 1/2, the base of the triangle is S, and the height is 1/2 S root 3. And if I multiply my numerators together, 1 times S times 1 times S is S squared times root 3. S squared times root 3. Denominator, 2 times 1 times 2 times 1, 4. Add this to your list of formulas. The area specifically for an equilateral triangle, that's a cursive S, S squared root 3 over 4. Easy to remember, I call it the 2, 3, 4 formula. Side squared root 3 over 4. Side squared root 3 over 4. 2, 3, 4. Side squared root 3 over 4. Watch how great this is. Earlier, we did this problem. I'm going to find it if I can. Too many papers. Seems to be the one paper that disappeared on me. I'm sure you have it in your notes. If you're keeping notes, that's amazing. Literally disappeared. I'm a better magician than I thought. You can go back to the video and see, but check this out. Using this formula, S squared root 3 over 4, the area of this equilateral triangle must be side squared root 3 over 4. What's 10 squared? 100. Divide by 4, 25. 100 divided by 4, 25 root 3. That is the answer we had. I'm going to look one more time through my papers. Here it is. We did this earlier. Every side was 10. We had to do a whole bunch of work to get the area. There was the answer, 25 root 3. But now you can do that kind of problem in your head with this formula that is not in your book. Equilaterals only, side squared root 3 over 4. So quick mental check for you. Can you figure out the area of this equilateral triangle? I'll give you 5 seconds. Answer is side squared root 3 over 4. 16 divided by 4 is 4. Answer is 4 root 3. All right, that's going to do it for today. Why is my camera moving again? I have to get a new videographer. Hope you guys got something out of that. I'll be back in the next video with another formula that's not in your book, so look forward to that. Bye-bye.